Alright guys, so I made a video similar to this a couple years ago. I'd say a couple years, probably about 5 or 6 years ago. I think it was my 200th video, I think what it was, because we made a shop fan out of a blower that was smaller than this. This is still 120 capacitor start. This is a 4-speed, which I think that other one was too. I took this out of a old gas furnace that was getting ready to be junked, and it looked like it was in pretty good shape. This part was. The rest of the furnace was junk. So what we're going to do, this is going to be the bottom of it, so we're going to build a little base for it, probably out of wood, just to add a little bit of weight to the bottom of it. And this time I'm going to paint everything. I got a different type of switch to put on it. This was last time I had a toggle switch. It was on, off, on, which selected 2 speeds. This one I want to be able to select any of the 4 speeds. I already checked it and it works. So I'm going to save the circuit board just in case we need something, you know, for our furnace or my dad's furnace or something, because his has a board that looks similar to this. So hopefully, you know, maybe something will work off of it, if not the whole board. But who knows, it might be shot too. But or maybe we can use one of these relays for a project or something. So this is also a 24 volt, I believe it is. Yep, 24 volt transformer, control transformer, so that'll be handy to have for something if it's good. Like I said, capacitor start, the capacitor right here. On these multi-speed motors, you usually have 2 brown wires like this for the capacitor. That way they can be easily identified for that. White's the neutral, and the other 4 colors are the different speeds. We'll look at the motor here in a second. So it's a GE 3/4 horsepower. Here's the specs on it. The capacitor, 370 microfarad it looks like. Wiring diagram for the speeds and the capacitor. Black is the high speed, blue is the next speed, orange, and red's the slowest. Then white's obviously the neutral, it connects to the other line. So you never want all these connected. You have to make a selection between one of these for each speed. And so we're going to use a rotary control switch for that. This is also a ground wire. So we'll hook up a regular 3-prong cord on it. So I want to do a few things off camera. I did already test it. Motor works. All 4 speeds do work. I don't know if the capacitor, you know, is good for like a long-term use, but if it gets hot and shuts off or some overheat problem, we'll check the capacitor first. But for now, we're just going to go with it. So I'm going to take this board off and all the extra wiring, and go from there. Alright, so it looks a little cleaner, don't it? Also, the video looks a little sharper since I wiped the camera lens off for the first time in like a year. So I put a little tip, always put zip ties on that conduit like that, just help keep everything in place. Some people use electrical tape. I like to use the zip ties that somebody just holds it better. You can tape over it if you want. These terminals will probably be coming off because we got a weird setup on this switch. So I ran the 4 hot wires, I call them, the 4 speed wires out of this one, and the neutrals out of this, along with the capacitor wires. Alright, so here's the switch I got. It's actually a 5-position rotary. It's got off, then the 4 speeds. You see 4 is hiding back there. But it's got a weird pin out on this. So there's a total of 8 screws. So in position 1, these 2 screws come in contact. Position 3, those 2 are in contact. And the same with 2 and 4 on this side. So you got to have 4 hot wires that are hot all the time coming off this, tied into your 1 hot cord coming from your main power supply cord. That's kind of a weird way of this switch. Most switches will have like a common connector than just your 4 selection, you know. But you know, it is what it is. So this is made to mount like this, but I like the more even flow of the switch in this position, so we'll make our own labels and put on that and put power switch or something down there underneath it. But this is going to be mounted in like a control panel right here out of metal. And we're probably going to have like plywood and 2x4 frame on here, just to add, like I said, add a little bit of weight to the bottom of it and have a base for it to sit on. Because you want the top of it to be the discharge part of the blower. We'll also probably make another baffle here, or a deflector maybe. And it seemed like it just needed a little bit of a load put on it, because these aren't designed to be ran open like this. You got to think this is pushing air into your ductwork system, so there's always resistance on it. So anyway, let's get the base made and wire it up, then go from there. So I was kind of concerned about how this switch was going to mount. You only have to drill a hole big enough for that square shaft to come through, so that makes everything a lot simpler. You can also position the knob in pretty much any position that you need, so that makes it very universal. It just has a little screw going into it. Alright, so you can kind of see what we got going here. Just notched that up with the jigsaw. Not the prettiest, but if I took the time, I probably would have just used a hole saw, but I thought this would be a quick and simple way to do it. So we got all the wires up here. Now we got to cut the control panel. If you got sheet metal to work with, it'd probably be a better choice to make this out of metal instead of wood, but just something I got laying around, some scrap pieces of wood. I really like having this wood base. It just adds a weight to it. I might get some legs to put onto it, little rubber legs or something underneath of it. That way if you set on like a concrete floor or something, it won't try to walk away or anything. Yeah, it's turned out pretty good. I like the way this works. Of course, we'll have some like chicken wire or something like that here just as a guard. This is a pretty good size blower. Like the opening on this is 13 inches. The blower wheel itself is about 10, so that's a decent sized blower. I'd say it's about 30% bigger than that other one we built a few years ago. Alright, so I got the panel made on here. Another piece of that metal shelf I've been using for everything. I just left the edge on here. This is left over from the engine stand. So I've got self-tapping screws in there. Might come up with some way of covering that. They're not super sharp. Might be cut them off later on. One got in here into the wood just to keep it from rattling or anything. So now I got to mount the control switch and go ahead and do the wiring. So you actually have to drill a total of 5 holes to mount this switch. So you just kind of see how this works. This will go on, and this will go on to cover up the holes, and the knob goes on. Alright, so here's my version of the spaghetti. It's actually not as complicated as it looks. So we got a red wire coming in. Ordinarily it would be a black wire, but I nicked it and I just went ahead and took that off. So that'd normally be a black, it don't matter. Spliced into 4 wires. So 1 red wire into 4. So that forms what normally would be a common. So it's actually 4 separate switches in this. So the red from the motor, I just made these little extensions here. Put a disconnect on this end and a spade connector on this end just to make it a little neat, a little bit more reliable. So red's low speed, orange is the second speed, blue's the third speed, and black's the highest speed. So that's all the wiring. I might put a couple zip ties on it just to dress it up a little bit more, I don't know. But I just got to put the plug on the cord and should be good to go. Made the cord about 6 foot long, so that's about a typical cord. I started making it longer, but I didn't want to use up all my wire. This is a 16 gauge Carroll cable. It's actually 4 conductor. I bought this from a 3-phase project a couple years ago. I put a couple zip ties in there just to tie everything together. I don't know if I mentioned, but there's also a ground wire that comes up here and contacts the metal. It also ground the plate through the screws once this is installed, so everything's properly grounded so it'll be safe. And I also just ran this wire out through here, through that notch right there. And I tied a knot in there to keep it from pulling out, so hopefully that'll hold up. I taped all the connections just to keep it from vibrating loose, or in case there's a stray wire or something don't come in contact and short everything out. So, alright, let's get a plug on here and make sure it works. Alright guys, we're ready to test it. I got the plug put on there and got it mounted. The first test, I haven't actually tested it yet. I thought we'd do it together. That way, if one of 3 things will happen in a situation like this. We'll plug it in and it works perfect. Plug it in and it don't work at all. Plug it in and it goes up in smoke. So let's see what happens. Alright, plugged in. Speed 1. Also make a note, make sure you don't have nothing laying around here. It'll get sucked up into these. These things are really powerful and they're bad about doing that. Even just on one, it's a lot of air coming out. You don't want to stand in front of one of these when you first plug it in, because you can get sawdust and metal shavings and stuff blowing out. You don't want to get it in your eye. That's a really powerful and really quiet fan. Alright, since it didn't go up in smoke and seems to be working good, now we can proceed to painting it and all that good stuff. Which most of it's going to be done off camera. We're also going to put a handle up here and 2 holes pre-drilled. Probably won't line up or nothing. I got a small handle, might pick up something bigger or just make something out of pipe, electrical conduit. Got to relabel the plate on here, and almost thought about putting indicator lights on there, but there's not much need in it. I don't know, we'll see. Or maybe just one light to show the power's on or something. I don't know. Just thinking out loud. So yeah, we've got to paint it. And probably going to paint it black. That's my standard color for just about anything. I was going to take it all apart and paint the blower itself a different color, but it's just too much work. It usually gets stuck on the shaft. This one don't look too bad, but you never know. And also, we're going to put some shielding on here. I don't know exactly what I'm going to use yet. Maybe just a piece of chicken wire or something on this side, because it'd be kind of hard to get into this side. But I like to have an actual guard on this side, and maybe almost like a vent, or you know, like a air register kind of thing going on this. I don't know, we'll see. Because that'll put a little bit of load on it too, like I was talking about, where these are made to have a little bit of a load on it. So let me get some more stuff and we'll go from there. We'll get the main part of it done. So I went ahead and painted the bottom of it with water-based paint, just some black semi-gloss latex that's left over from painting the walls. So just one coat, just enough to kind of protect it a little bit. So I'm going to go ahead and prime the wood part off camera just so it'll take the paint a little bit better. And I did go ahead and order some lights for it, so we'll do that at some point. Probably go ahead and drill the holes for it before it's painted, that way I can just install it. I might just go ahead and take the switch off. All I got to do is loosen them 4 screws, and all the wiring and everything will stay in there. That way I don't have to mask it off. Or I might just take the cover plate off and the knob, just to make things simple. I might just do that. Probably not going to show none of the paint on camera. We'll just look at it after it's done, just to keep from making the video too long or boring. So I went ahead and put some primer on here, just some primer I had laying around, just to help soak into that wood a little bit, the way it'll take the paint better. So I got the 4 indicator light holes drilled, spaced them 1 inch apart, mask the motor off. Like I said, I want to keep this plate the silver looking, and I almost thought about keeping the motor that gray color, just because I like the way like a factory style motor looks. So we might just go ahead and mask the whole motor off. I might lay a rag or something over top of the wheel here to keep from getting overspray on it, because I kind of like to keep that silver if possible. I'm sure I'll get overspray on it somewhere, but you know, we'll try our best. Alright, so it's painted. I used Rust-Oleum, and I didn't detail the inside part right there. I did mask off the motor just to keep it from being all black. There's me. And got pretty good shine on it. It's not clear coated or anything, just a regular Rust-Oleum spray paint. I made the label for the switch. It's not exactly pointing at 1 and 3, but I think it'll be just fine. I'm just trying to do something quick and easy on that. Like I said, I got lights ordered for these, and I just made the labels for it, and we'll explain all that here in a little bit. Even masked the ground wire off. So alright, let's let it paint cure for a few days, and we'll get back at you later. Alright, so here's the lights I got. They've got a resistor and a diode in here to run off 120 volts AC. So I'm going to put these in off camera. We'll look at the wiring before I close the panel back up. Also got the handle and the little rubber feet to put on it. These are like for a guitar amp, so that'll should work pretty good. I was hoping that handle would be a little bit bigger than that, but it'll work. Okay, so I got everything wired up. Got all the grounds hooked in here, and just put a wire nut in there. I got to tape that one up. Hooked each red. I just stuck it up underneath the terminal, tightened it down good, gave them all a good pull, and make sure they're on there good. You gotta make sure you hook it on the output of the switch. If you don't, they'll all be on all the time. So if you wanted to hook one up just as a power light, letting you know that it's plugged in, you know, you could just obviously run the ground to this and just come off of one of the hot wires here. It comes right off the power cord, and it'd be on all the time as long as it's plugged in, but I didn't want to do that. I was originally thinking about just tying into this ground to put another thing on there. I was thinking, well, if it's ever plugged into a GFCI, it might trip it where there'd be current coming back on the ground instead of the neutral. So, alright, let's put it all back together and make sure it works. Alright, so we have a problem. So they're all coming on in each selection. And as soon as I seen it do it, I realized what the problem is. So on a motor like this with multiple speeds, it's almost like an auto transformer where there's like taps in the windings. So it's just back feeding power back through the winding. Didn't even think about it at all until I seen all of them come on, and it just dawned on me instantly. So the only thing I know to do, either just leave it like it is, just have all 4 of them come on, or possibly have like a coil around each one like an inductor, because it's only going to have amperage on each selection, but the voltage is always going to be there. That way it would induce a current into the coil and be enough to light a little LED like this. It's the only thing I can come up with. I'll have to do some research and see what I can find, so get back to you on that. Okay guys, so this is what I came up with. I just tested it and it will work. So this is a current induction coil, I believe is what it's called. If not, it's been a while since I ordered these. I'll put what it's actually called up here, and your wire will go through this. Like in this case, it's going to be each one of the speed wires is going to go through a separate one of these. I got a whole pack of them here. And these are actually for Arduino, or never could say it right. Arduino or whatever, you know what I'm talking about. That's actually for these, but it lit up an LED pretty bright, and so we're going to go with it. So we wire it up and everything. It's pretty simple. Your LED just pretty much hooks straight to this. I'm going to use the existing diodes when I'm bypassing the resistors that's on these, because these resistors are set up for 120 volts, and it's not going to be that much. Put a voltmeter, it's like 4 volts before the diode, so it's probably about 3 after, because sometimes you have a slight voltage drop past the diode, and plus you only get half of the wave anyway, so it should be fine, I would think. Not like this thing's going to be on 24/7 anyway. Alright, so it's all done, it's working. We'll look at it here in a minute. I just got to tape everything up, but I wanted to share it with you first. So, you can see there's one of these little things, these little inductive coils, the wire, one for each speed. So, the problem was, when I hooked the light up to each one, the motor, with multi-speed motors, are kind of like a auto transformer. It's almost like there's different taps in the windings. And so I was getting voltage on all 4 speeds when any of the speeds were on. I got thinking, the only time there's amperage on one of these wires is when that speed's on, completing the circuit. So the voltage was always there, but the amperage was only on the one that was being used. So the closest thing I can compare this to, there's 2 things that come to mind. If you're familiar with the old inductive timing lights for like older vehicles with a distributor, you get that clamp that goes around like number 1 spark plug wire. It's the same thing going on. It's inducing a current into the coil on this. In this case, it's running to the light. Also, the only other thing I could think of would be an amp clamp, which works off the same principle. You run the wire through it, and it tells you how much amperage is in the wire, which is actually what these are intended for, is to be like sensors for a circuit, but they're just being used for indicators here. So it works. I already tested it, and I went ahead and put the labels on it. Alright guys, so I'm going to call it done. The only thing left to do is build and install the heater attachment for it, which may or may not work, so that'll be a separate video. The main blower part's done, fully functional. I really like the feel of that switch. I love the lights being like that. Do I recommend going to all the trouble to put the indicator lights on there? No. that was a little excessive. I wasn't planning on that. And I already had these holes drilled and the lights mounted and everything before I ran into that issue. So that's the main reason I went ahead and went forward with that. So the cost of adding the lights to it, I think, is about $20, $25, I think, what it came out to. And that's including one extra indicator and one extra coil in there. So that's not too bad, I guess, but the switch was $10 or $11, so we got $30 just in the controls, when honestly, if you're just going to use one speed on one of these, you just put one toggle switch selecting that speed. But you know, I got to take things to level 2. And you don't, obviously you don't have to paint it either, but I just wanted to make it look nice. Do highly recommend putting some type of guard on this, even if it's just a piece of like chicken wire or something, just as long as it keeps some fingers out of there is the main goal. But anyway, went into a little bit more detail than I was planning on this, but I just kind of wanted to make another. I don't know if I mentioned or not, but I did put a handle on it, and it's also got rubber feet on it. That's for a guitar amp, so that should hold up pretty good. So, alright guys, so like I said, there'll be a separate video at some point if the heater attachment's doable and workable on this, so we'll kind of play that by ear. But anyway, it's we're gonna call it done. So now it's time to cool off, and thank you guys for watching, and we'll catch you on the next one.